A Hamiltonian circuit, unlike an Earlian circuit, involves the visiting of each vertex or each point of interest once and once only. An Earlian circuit, remember, every single edge has to be covered. An Earlian path, every single edge has to be covered, but you start and finish at a different point. Now, Hamiltonian circuit, there's quite a few in this particular problem. Starting and finishing at A, I'll just do the A, B, C, D, E, and A. Back to A. When you state these, make sure that you've got the start and the finish the same. An Earlian circuit, starting and finishing at A, on the other hand, is simply not possible. And when you state that, you must say why. C, vertex C, and vertex C, sorry, it's just the one. It's unusual. Vertex C is of an odd degree. And E is as well, sorry. There's two. In turn, that means an Earlian path is possible. C and E are odd. Obviously, the rest are even. And if I had to illustrate that, I could start at E, going to A, back to E. They tend to fall into place pretty much regularly. Just make sure you're giving yourself enough room to finish at C. Now I'll just stop the tape and quickly write down my answer. So there's my Earlian path in that case. Now a Hamiltonian path from D to C must encompass all the points. So if I started at D, went to E, A, B, and end up at C, that would be a Hamiltonian path. In the case of E, from D to A, I could go from D to E to C to B to A. That would cover the Hamiltonian path requirement there. In the case of F, E to B, E to D to C to A to B. Now, in part G, E to B, it's not going to happen because we've got so many paths joining E and B, it's simply not possible. Let you have a bit of a think and investigation on that for yourself.